Right now, as you sit there listening to this, the entire universe could be coming to an end. It wouldn't happen with a roar or a flash of light. You wouldn't see it coming on the news, and you wouldn't have time to say goodbye. At the speed of light, a bubble of total transition could be sweeping through space, rewriting the laws of physics and erasing every atom of our reality before the electrical signals in your brain even have the chance to register a thought. Scientists call this false vacuum decay, and it is arguably the most unsettling possibility in all of modern physics. It is a theory so profound and so absolute that it makes every other cosmic threat, from asteroid impacts to the fading of our sun, look like minor inconveniences. We like to think of the universe as a stable, solid place with rules that never change. But what if the very foundation of our existence is actually built on a cosmic mistake? What if we are living on a ledge and the ground beneath us is waiting to give way? To understand how the universe could simply switch off, we have to talk about the concept of fields. In physics, everything we see, from the chairs we sit on to the stars in the sky, is just a ripple in an underlying field. Think of it like a giant invisible fabric that covers the entire universe. There is an electron field, and when it gets excited, we see an electron. There is an electromagnetic field, which gives us light, but the most important one for our story today is the Higgs field. This field is what gives particles their mass. Without it, nothing in the universe would have weight. Everything would zip around at the speed of light, unable to form atoms, planets, or people. The Higgs field is the glue of our reality. Now imagine a ball sitting on a hill. In physics, everything wants to be at the lowest possible energy state. The ball wants to roll down the hill until it reaches the valley at the bottom. Once it's in that valley, it's stable. It is at its vacuum state, the state of lowest energy. Scientists used to assume that our Higgs field was already at its lowest possible energy state. We thought we were in the valley. But when the Higgs boson was finally discovered and measured a few years ago, math revealed something terrifying. Our Higgs field might not be in the valley after all. Instead, it might be stuck in a slight dip on the side of the hill. This is what we call a false vacuum. It looks stable. It feels stable. It has stayed there for 13.8 billion years. But it isn't the absolute bottom. There is another, much deeper valley below us. And in the world of quantum physics, if there is a lower energy state, the universe eventually wants to get there. So what happens if the Higgs field suddenly decides to roll down to that true valley? This is the core of the theory. It starts at a single point, a tiny microscopic fluctuation somewhere in the vastness of space. This is called quantum tunneling. It's a phenomenon where a particle or a field essentially teleports through a barrier it shouldn't be able to cross. If this happens to the Higgs field at just one point, it would create a bubble of true vacuum. Inside this bubble, the laws of physics are completely different. The Higgs field is at a lower energy, and the constants of nature, the things that determine how strong gravity is or how atoms stay together, are rewritten. This bubble would then expand in all directions at the speed of light. Because it moves at the maximum speed of the universe, there is no way to detect it before it hits you. If a bubble of true vacuum was triggered a few light years away, we wouldn't see it coming. There would be no signal, no radio warning, no visual flash. 1 second, you are drinking your coffee, and the next, the atoms in your body no longer follow the rules of chemistry. You wouldn't even have time to feel it. You would simply cease to be part of this reality. This isn't just about us, though. This is a cosmic reset button. As the bubble expands, it consumes everything in its path. Stars, galaxies, black holes, and civilizations are all wiped away as the space they occupy is overwritten by the new, true vacuum. It is the ultimate erasure. And the most terrifying part? The new laws of physics inside that bubble might not even allow for the existence of matter as we know it. It could be a universe of pure radiation, or a universe where gravity is so strong that everything collapses into a single point immediately. Our version of life is a specific miracle that requires the exact settings we have now. If those settings change by even a fraction, the story of life is over. Now, many scientists don't like to talk about this because it feels so hopeless. In science, we usually look for problems we can solve, or at least observe. But you can't observe false vacuum decay because to observe it is to be destroyed by it. It's a theory that sits at the edge of our knowledge, a ghost in the machine of our mathematics. Some physicists argue that the fact we are still here, billions of years later, suggests that our vacuum is metastable, meaning it could stay this way for trillions of years, far longer than the life of our sun. But quantum tunneling is a matter of probability, not a matter of if. In an infinite universe over an infinite amount of time, any probability that isn't zero will eventually happen. But let's look at why this theory is coming to the forefront now. It's because our understanding of the early universe is getting better. We are realizing that the universe went through several phase transitions in its first few seconds. It was a chaotic, high-energy environment where the forces of nature were constantly changing and splitting. Gravity, electromagnetism, the strong and weak nuclear forces, they weren't always separate. They crystallized out of the cosmic soup as the universe cooled. The Higgs field was part of that process. It froze into its current state. The fear is that this freezing process wasn't perfect. Like a piece of ice with a crack in it, the universe might have a flaw. If we live in a metastable universe, we are essentially living on a cosmic time bomb. But there is a twist to this story that makes it even weirder. Some theories suggest that false vacuum decay might be how universes are born. This is the multiverse angle. Imagine our universe is just one bubble in a much larger landscape of energy. Perhaps a bubble of true vacuum in a higher dimension universe is exactly what a Big Bang looks like from the inside. We might be the result of a vacuum decay event that happened in a parent universe. Our beginning was someone else's end. And if that's the case, our own decay might just be the spark for a new universe to begin, one with its own stars and perhaps its own version of life that we can't even imagine. This doesn't make it less terrifying for us, but it changes the context. Instead of a random ending, it becomes part of a cycle. However, when we talk about things that scientists don't want to talk about, we are also talking about the philosophical implications. If the universe can end at any second for no reason, what does that mean for our struggles, our achievements, and our history? It's a level of nihilism that is hard to digest. We are used to the idea that we can at least leave a legacy. Even if Earth is destroyed, we hope our signals will travel through space, or our probes will be found by someone else. But false vacuum decay leaves no survivors and no records. It is the absolute deletion of the past. Despite the darkness of the theory, there is something incredibly beautiful about the fragility it implies. It means that every second the universe remains in this false state is a gift. The fact that the Higgs field has remained tilted on that hill for 13 billion years is what allowed galaxies to form. It's what allowed heavy elements to be forged in the hearts of stars. It's what allowed you to exist. We are living in a temporary window of physical perfection. The emptiness of space we talked about in other theories might be silent, but it is at least stable. This theory suggests that even the silence isn't guaranteed. There is another theory that scientists find equally disturbing, and it relates to how we perceive time. It is called the Boltzmann brain paradox. This theory stems from the same idea of quantum fluctuations. If the universe is a place of random movements, eventually, those movements will arrange themselves into something complex. Usually we think this takes billions of years of evolution, but according to the laws of probability, it is actually more likely for a single, fully formed brain to spontaneously materialize in the vacuum of space, complete with memories of a life that never happened, than it is for an entire universe to evolve over billions of years. This means that you, right now, might not be a human on Earth. You might be a Boltzmann brain that just flickered into existence in the dark void of the distant future. Your memories of childhood, this video you are listening to, the feeling of the chair beneath you, they could all be a random statistical fluke. In a second, you will dissolve back into the void. This idea is so mathematically sound but logically horrifying that physicists have spent years trying to find a flaw in the math just so they don't have to believe it. They are trying to find reasons why the universe prefers to make real humans rather than ghost brains in the dark. Both false vacuum decay and Boltzmann brains point to a single uncomfortable truth. Our reality is much thinner than we like to admit. We are like ants living on the surface of a giant balloon that is being inflated. We feel like the ground is solid, but we don't realize how much tension is in the rubber. Scientists don't avoid these topics because they are forbidden, but because they challenge the very foundation of how we do science. Science is built on the idea of cause and effect, of observation and prediction. But how do you predict a random quantum event that moves at the speed of light? How do you build a model of a reality that might be a hallucination of the void? When we look out at the vast distances of space, we see light from stars that burned out millions of years ago. We are looking into the past. We see a universe that appears consistent and reliable. We see the orbits of planets that haven't changed in eons. This gives us a sense of security. We feel like the universe is a machine that will keep ticking forever. But the most terrifying theory tells us that the machine has a flaw in its programming. There is a divide by zero error waiting to happen in the vacuum. But let's pivot for a moment to why we might be safe. Some researchers believe that the energy required to trigger a vacuum decay event is so high that it can't happen naturally. They look at high-energy cosmic rays, which are much more powerful than anything we can create in a particle accelerator. These rays have been crashing into planets and stars for billions of years, and they haven't triggered a collapse yet. This suggests that the hill the Higgs field is sitting on is much more stable than we think. It's not a ball on a smooth slope, but perhaps a ball nestled in a deep layer of sand. It would take a massive, universe-shaking event to nudge it over the edge. There is also the theory of supersymmetry, which many physicists are hoping is true. Supersymmetry suggests that every particle we know has a twin particle we haven't found yet. If these twins exist, they would change the math of the Higgs field. They would add extra stability, essentially smoothing out the hill and making it so that there is no deeper valley to fall into. For many scientists, finding proof of supersymmetry would be a massive relief. It would be the proof that our reality isn't just a temporary mistake, but a permanent, stable home. However, as we search for these answers with massive experiments like the Large Hadron Collider, we are playing a high-stakes game. Some people were worried that by smashing particles together at such high speeds, we might accidentally trigger the very decay we are afraid of. Scientists have done the math and assured us that this is impossible, but the fear remains in the public consciousness. It's the idea that human curiosity might one day bump into a cosmic tripwire. Why does this matter to you? Why should you care about a bubble of true vacuum or a floating brain in the void? It matters because it changes our perspective on the here and now. When you realize that the universe is under no obligation to continue existing, you start to see the value in the present. We spend so much of our lives worrying about the future, about 50 years from now, or 100 years from now. But the universe exists on a scale of billions of years, and it can change in an instant. This makes the human experience, even our tiny, brief lives, feel incredibly significant. We are the observers who are witnessing the universe while it's in this beautiful, false state. The silence of the universe we talked about before, the emptiness that seems so terrifying, is actually our best friend in this scenario. If the universe were crowded and chaotic, the chances of a vacuum decay event might be higher. But the vast, cold distances between things mean that even if something goes wrong in a distant galaxy, it will take millions of years to reach us. While the bubble moves at the speed of light, the universe is also expanding. In some models, the universe is expanding so fast that a vacuum decay bubble in a distant part of space would actually never reach us. The space between us would be growing faster than the bubble can travel. In that case, the universe could be ending in a million different places right now, and we would never know. We would be safe in our own little pocket of the old reality, tucked away like a safe haven in a changing sea. This brings us to the Big Rip, or the heat death of the universe. These are the traditional ways the universe might end. In the Big Rip, dark energy gets stronger and stronger until it tears apart galaxies, then stars, then atoms themselves. In the heat death, the universe expands until everything is so far apart that no new stars can grow, and the existing ones slowly go out like candles in a dark room. Most scientists find these theories much more comfortable because they are slow. They take trillions of years. They give us time to think, to plan, and perhaps to find a way to escape to a younger universe. But false vacuum decay is the wild card. It's the ending that doesn't respect the timeline. If you are a space enthusiast, you probably love the idea of universal constants. These are numbers like the strength of gravity or the speed of light that seem to be the same everywhere. They are the bedrock of our science. But if vacuum decay is possible, then these constants aren't actually constant. They are local values. They are just the settings for our current bubble. Other bubbles could have different speeds of light, different strengths of gravity, and different types of matter. We are living in a specific neighborhood of physics, and there could be an infinite number of other neighborhoods with rules we can't even dream of. This idea leads us to the anthropic principle. It suggests that we shouldn't be surprised that the universe is stable enough for us to exist, because if it weren't, we wouldn't be here to ask the question. We are the survivors of a cosmic lottery. We live in a universe that hasn't decayed yet, and that's the only reason we are able to have this conversation. It takes the mystery out of it and replaces it with a simple statistical fact. We are here because the vacuum hasn't collapsed here yet. Scientists don't want to talk about this theory not because it's a secret, But because it's a scientific dead end, if the theory is true, there is nothing we can do about it. If it's false, then it was just a scary bit of math. It doesn't lead to new inventions, it doesn't help us travel to Mars, and it doesn't cure diseases. It is purely a reflection of the ultimate limits of our knowledge. It tells us that no matter how much we learn about the stars, no matter how many galaxies we map, there will always be a fundamental layer of reality that is beyond our control. Think about the sheer scale of what we are part of. There are trillions of galaxies, each with hundreds of billions of stars, and all of it, from the largest black hole to the smallest grain of sand on a beach, is held together by fields that could, in theory, shift their state. It is a level of fragility that is hard to hold in your head for long. It's like looking at a beautiful glass sculpture and realizing it's being held up by a single thread that is under immense tension. You can appreciate the beauty, but you can't help but wait for the sound of it breaking. But here is the reassuring part. If you can call it that, if false vacuum decay hasn't happened in 13.8 billion years, the mathematical odds of it happening in your lifetime, or in the next 10,000 years of human history, are astronomically small. We are talking about numbers with so many zeros that the human mind can't even process them. We are much more likely to be hit by a rogue planet, swallowed by a black hole, or destroyed by our own technology than we are to be erased by a quantum vacuum collapse. So why do we find it so terrifying? Because it represents the loss of control. It represents a universe that doesn't care about our effort or our wisdom. It's the ultimate unknown. We can track asteroids, we can see suns aging, we can plan for climate change. But we can't plan for a change in the laws of physics. It's the one thing that is truly outside our sphere of influence. This theory also touches on the great filter we've talked about in other videos. What if the reason we don't see any advanced civilizations is because eventually, someone, somewhere, tries an experiment they shouldn't have? What if a civilization reaches a point where they can manipulate the Higgs field and they accidentally trigger a collapse? In this scenario, the filter isn't a war or a resource shortage, but a scientific accident that clears the entire slate of the galaxy. It's a haunting thought that the pursuit of knowledge could lead to the ultimate silence. But again, the physics suggests that the energies needed are so high that even the most advanced aliens would struggle to reach them. The most terrifying theory is really a story about our place in the cosmos. It's a story about the search for stability in a universe that is fundamentally changing. It reminds us that we are part of a giant, ancient, and complicated system that we are only just beginning to understand. The Higgs field, the vacuum of space, the speed of light. These aren't just abstract concepts in a textbook. They are the walls of our house. And while we've spent our time painting the walls and looking out the windows, we are only now starting to look at the foundation and realizing it might be built on a shifting landscape. As we peer deeper into the heart of matter, we will surely find more theories that challenge our comfort. That is the nature of science. It's the process of trading comfortable myths for uncomfortable truths. But every uncomfortable truth also brings a sense of wonder. The fact that the universe can be so complex and so fragile, yet stay together long enough for a species like ours to evolve and wonder about it, is the greatest mystery of all. We are like travelers in a forest at night. We have our little lanterns, and we can see a few feet in front of us. We've mapped out the trees and the paths near our camp. But beyond the light of our lanterns, there are things moving in the shadows. There are forces at work that have been there since the beginning, and they will be there long after our lanterns go out. False vacuum decay is one of those things. It is a shadow at the edge of the light. We don't have to fear it, but we should respect it. It is a reminder that the universe is much bigger, much older, and much more mysterious than we can ever imagine. In the end, the theory scientists don't want to talk about is a testament to the power of human curiosity. We have used our minds to uncover a potential flaw in the very structure of space-time. We have looked at the math and seen the possibility of our own erasure, and instead of turning away, we have double-checked the calculations. We have built giant tunnels under the Earth to test the fields that hold us together. We are a species that wants to know the truth, even if the truth is terrifying. So when you look up at the stars tonight, don't just see points of light. See the vast, invisible fields that connect them. See the incredible balance of forces that allows those stars to burn and planets to turn. And if you feel a little shiver of dread at the thought of a false vacuum, let it be a reminder to live fully in the reality we have. Because for all its flaws and all its fragility, this universe is our home. It has given us everything we know. And as far as we can tell, it's not going anywhere tonight. The cosmic reset button might exist, but the story is still being written. We are the authors of our own part of that story, and we have a lot more to say before the final page is turned. The mystery of the vacuum is just one more chapter in our exploration of the unknown. It's a reminder that the universe is full of surprises, and that the greatest discoveries are often the ones that make us question everything we thought we knew. Keep exploring, keep asking the difficult questions, and stay fascinated by the incredible, fragile, and beautiful cosmos we inhabit. The truth might be unsettling, but it is always worth seeking. And who knows, maybe by understanding the flaws in the universe, we will eventually find a way to transcend them. Until then, we have the stars, we have the science, and we have each other. And in a universe that could end in an instant, that is more than enough. The silence of the void isn't just an absence of sound, it's the presence of a vast, untapped potential. Every discovery, every theory, every moment of wonder we experience is a victory over the unknown. Even if our reality is metastable, our will to understand it is absolute. We are the thinkers, the dreamers, and the scientists who look into the abyss and see not just darkness, but a puzzle to be solved. And that, more than anything else, is what makes us human. So, as we move forward into a future where our understanding of physics will only grow deeper, let's carry that sense of wonder with us. Let's not be paralyzed by the theories that scare us, but be inspired by the fact that we can conceive of them at all. The universe is a playground of infinite possibilities, and we are just starting to learn the rules of the game. Let's play it well, let's play it with courage, and let's never stop searching for the next piece of the puzzle, no matter how terrifying it might seem. Thanks for joining me on this journey into the deepest and most unsettling corners of modern science. It's been a wild ride through the fields and vacuums of our reality, and I hope it's given you a new way to look at the world around you. Stay curious, stay bold, and keep looking up, because the universe still has plenty of secrets waiting to be uncovered.